Hey, good morning, everyone, and thank you very much, Brent. And thank you so much, first and foremost, Zebra team. You have really set up here a fantastic event. Really, actually happy and feeling honored to be part of it. Thanks very much, Mark and team. I'm Ralf Kodritsch. I'm with NXP already for almost 20 years now. I'm based in Austria. And actually, I'm heading the UHF business in NXP. And today I want to talk about the future of data-driven solutions and what it takes to get there. This year, the world is going to generate 180 zettabyte of data. This is a mind-boggling number, and it's actually even getting more going forward. And what is even more mind-boggling, just in the last 3 years, the humankind has actually generated more data than it's in its entire history. So think about it. Data is actually the big thing for us. Data is everywhere. We generate data every day, every minute, every second. 10 to the power of 21, it's actually a 1 with 21 zeros behind. It's a number which no one really can imagine what it really means, and we call it zettabytes. And actually the pace of increasing, it's even increasing pace going forward in generating data. Now, how come we have generated so much data, in the last year and just very recently? Generating data is really happening, as I said, all the time. Think about the car. If you think that this is a mobile device, I think you're wrong. The car is the ultimate mobile device. A, it's really mobile, and B, actually this has more semiconductor content than any of those phones. The car has more computing power than any of the phones or computers have. The car is the ultimate mobile device, and the car is generating data already today, and it's going to get even more. So the number of semiconductors in the car is also increasing day by day. Look at the homes. We talk about smart homes. You have actually Wi-Fi networks at home. All of your products are getting more and more smart. They are all connected to a network. They are all generating data. That adds to the 180 zettabyte actually this year. Think about smart factories. Also there, more and more data is being generated every day, every year. And then very importantly, healthcare, the healthcare sector where, there's a lot of data coming from, a lot of examinations. All the data needs to be stored. And also this is going to increase over time. And then finally, communities, cities, they all generate data. So this is basically where all this big pool of data is coming from, or even just think about your cell phones and all the data you generate by taking pictures and so on. So that's where these 180 zettabytes are coming from. Data is the new gold. We all know it. Data is basically the basis on which our industries are functioning. Data is needed in order to make the right decisions. Data is needed in order to drive businesses. Data is needed to make businesses more profitable. So, as we heard it before, data is kind of a currency. And if you get something for free on the internet, then you get it because you are the data. You are giving something which is your data. So without data, I think you would all agree that the industry would not be there where it is. And I think no one would really argue the importance of data. Now, how come, this is the RFID forum, and how come that in 2025, or actually in 2024, only 53 billion tag ICs were sold? Can we really be happy about the number? I think it's a great number, no doubt about it. But if you think about all the data generated everywhere, I think the industry can do better and has to do better. But how do we get to the trillions or the hundreds of billions, or actually even the trillions? I want to talk about it during my talk, actually, how to really get there. Because I think it's a great achievement from the industry, And you have seen actually the exponential growth of the RAIN RFID industry when it comes to tag ICs. But I think this has taken like 20 some years. I think we can do much, much better as an industry. And we want to get to the hundreds of billions and the trillions as quickly as possible. But we know that getting there, actually, there are challenges. But you can call it a challenge, and you can turn it into an opportunity. We have challenges because just think about, we are dealing with the physical world. Yes, there are very RFID unfriendly materials out there. Yes, there are certainly items which are super, super small, which are very difficult to tag. We as an industry have to overcome those challenges. And I think we've already come a very, very long way. Just think about 20 years ago, the sensitivity of the chips was really, really poor. Meanwhile, the sensitivity has increased enormously. I remember discussions where we said, where will there be an end? Like 20 years ago, they thought it's maybe, in the range of whatever dB. We far, far exceeded it already. And I think there's much, much more to be done to really turn every product into a smart product. Now, with actually the evolution of the chips, we have now smaller inlays. We have better readers out there in the applications. So all that has helped, of course, to drive the adoption of RAIN RFID. But like I said, I think we got to be more ambitious, and we got to get to the trillions. The quicker, the better. But I don't think that just slapping an RFID label onto a product will get us there. I think it can only be a combination of technologies which is getting us there. It's not about just the fact that you put a label on the product and this is it, and it will resolve all the problems. No, there is so much more to a product than just reading an EPC code, for instance. So that's why I think the RAIN RFID industry can get to the trillions with the help of other technologies. And it's always other technologies, or it can be other technologies, which complement actually RAIN RFID. And by adding other, I would say, intelligence, this will then also drive the number of RFID labels. And this is actually what the industry wants. That basically means more readers, more system integration, more everything. So unlocking those trillions of data points, this is actually what NXP's vision is. And NXP's vision is not to do it only with RFID. It's really a much, much more holistic approach, we think. Now, how can we tag everything? And as I said, it's a difficult thing because every item has a different form factor. Every item consists of different materials, meaning that you have to have maybe for every item a different tag, a different setup. So how can we do that actually at the end of the day? And there is this promise of RAIN RFID. It's about reliability. I think a UHF system has to be reliable. The setup of a RFID system has to be easy, and it has to be reliable. Think about the old days. Think about your TV set at home. It's really a long, long time ago where you still had, these antennas, and where you had to actually adjust the antennas so that you're picking up the signal and that you could actually watch TV. Sometimes I have the impression that this is still the case in RFID. Then once you have set it up correctly, guess what? Bad weather comes and all is changing again. This should not be the case for RAIN RFID. It has to be robust, it has to be simple, and it has to be reliable. Meaning all the components need to be robust and simple and reliable. That's really key to a successful implementation, and I think all of you who have done it know what I'm talking about, and we really need the help of system integrators who can really drive such implementation. that everything works reliably. Interoperability. This is another big topic, and I'm a very firm believer, and this is very, very important for the end user. You may want to change from company A to company B for whatever reason, but that should be possible. You should not be locked in because you have started with company A, and you cannot go to company B, because if you change that, you know, if you're going from that label to the other label supplier, or from that reader supplier to the other reader supplier, and your whole system breaks down. That's not what I call reliability. This is not what I call interoperability. This is not what the industry needs. This is not what gets us to the trillions. Again, it needs to be all easy. Interoperability is a very important thing, and thanks to the standards, we have it. Sustainability, that's the other promise of RFID. And I think we cannot emphasize it enough. This is really a key thing. We heard it yesterday already when it comes to recycling. Product can tell you, you know, the components it is made of. The product can tell you actually how to recycle it. And sustainability is really something which is helping the industry in terms of profitability, and it's helping the planet in terms of CO2 footprint. You can actually avoid overproduction, for instance. And that all actually leads to sustainability, to profitability. Because at the end of the day, if you've got a system that works, if you've got a system that's reliable, if you have got actually happy customers, that at the end of the day is going to drive your profitability. So what should RAIN do? What should the industry do in order to get us to the trillions, in order to drive adoption? And as I said before, ease of implementation. It has to be easy, full stop. It may be a very simplistic view, but it has to be easy. Yes, we are dealing with physics, but hey, here are the experts in this room. We need to make sure that the end user can actually really have an easy and quick installation. This is our job, and if it was easy, well, the better it is for the end user. A standards-based approach. This is something which is really, really important. Again, referring back to the interoperability, you may want to exchange components for whatever reason. NXP is a big promoter of standards-based approach. NXP is a big, big promoter. We don't think that any kind of custom features, custom commands will drive the industry to the trillions. It's the standard-based approach, and thanks to GS1 and all the work which is going on there in the standards bodies, they are supporting that as well. And then the third pillar is actually quality, quality, and quality. I think those of you who are actually familiar with the University of Auburn know what I'm talking about. Quality is of utmost importance. It cannot be that you're using, you know, a number of labels in that DC, and then basically the same labels behave differently in another DC because you're using a different lot of labels. The performance of labels has to be as consistent as possible. The quality of labels has to be as consistent as possible. This is making the end user happy, and this is what really actually is also then reflecting on the industry as a whole. Because if you've got inconsistent quality, at the end of the day, it's really bad for the user, and it's really bad for us as an industry. So therefore, I cannot emphasize enough that the work done by the University of Auburn, yes, it may be tough and it may be cumbersome, but it's super, super important for the industry. And we totally support whatever the Auburn University is doing there. But as I said before, getting to the trillions is not about RAIN RFID only. We think that you've got to combine technologies. We think that you've got to combine what is out there in order to drive the RAIN adoption. Now, what does it mean? Let me give you an example here. You're certainly familiar with goods arrival. You know, we have got actually a truck coming to the dock store, and it gets unloaded. you've got a doctor reader, and then you basically know, okay, I'm receiving trays, and those trays are full of tomatoes, for instance. Now, I can check whether my trays have arrived at the dog store. I can check whether it is the right amount of trays. Did I really get my 100 trays, or did I get a few less? And then also, I can basically check, is it the right product, because the label tells me, hey, it's tomatoes in my trays, or it's apples in my trays. So this is what you can do very easily with RFID. Now, combining that with AI, for instance, will get you to the next level. So what we did actually in NXP, we did a demo, and I'm showing you a movie. What we did, we actually used some rotten tomatoes and actually fed that picture into a Gen AI system supported by NXP silicon or NXP chips. Now, these are the tomatoes, as you can see. Some of them are rotten. And this is actually then the outcome. This is the result of feeding a system with those tomatoes. What was not possible before is possible today. And for all of those there in the back row who cannot read it, basically the outcome is, yes, based on the image provided, there appears to be at least one rotten tomato among the group of tomatoes shown. The rotten tomato has visible signs of decay, such as discoloration and possibly mold or rotting spots. This contrasts with the other tomatoes that look fresh and undamaged. This is what is possible today. This is what is possible with AI today. And again, I wanted to point out, this is actually done, a demo by us, with actually Gen AI and supported by NXP semiconductors. Believe it or not, there are other companies out there, not only NVIDIA is doing actually AI. So clearly, at the end of the day, then you need to make a decision what to do with all those tomatoes. And those tomatoes were just an example. It can be any other product, as you can well imagine. Now, I said I'm through with NXP. I said we do a lot of things, but let me basically go into a little bit more detail for those of you who do not know NXP. We're actually a $12.6 billion company, headquartered in Europe, in the Netherlands. More than 33,000 people, and actually present in more than 30 countries. If you really add the home offices, we are somewhere in the range of 50 to 60 actually locations worldwide. So we can serve you actually at your doorstep. We have a wide variety of products for the industry. You're familiar with UCode, which is our RFID product. We've got UWB chips. We have actually sub-gigahertz products, Wi-Fi chips, Bluetooth low energy, and NFC. So this is a wide variety which we can really serve many, many different use cases. And I want to point out, if you go to a store and you want to buy a tool, and that store only has one tool, guess what? They will only promote that one tool because they don't have anything else. If you go to a store which has a wide variety of tools, you will get much better advice. You will get advice whether RFID is the best product. You will get advice, maybe it's BLE. Maybe it's actually UWB. Maybe it's a combination thereof. NXP is not a one-trick pony. NXP has it all. NXP has a wide variety of products. So that's why we think actually the success really stems from the synergy of diverse systems working together. And that's what I said in the beginning. I think the adoption of RFID will come from a combination of other technologies, the support of other technologies, if I want to say so. Now let me give you another example here, for instance. Think about a logistic system, and we talked about a lot about RAIN RFID. I think not much more to be said about it. But you can actually add to your solution a UWB solution, actually. What does UWB mean, or what does it do? With UWB, it's ultra-wideband. You can really locate your product with very, very high precision. It goes into the centimeter, millimeter range. So basically, the reader Brand spoke about, which was somewhere misplaced on the third shelf, somewhere there in the corner, with UWB, you could really tell, hey, it is right there. I can really find it. It's right at that spot, because UWB gives you that precision. Sorry. UWB is used not only, of course, in logistics. Today it's used for car access keys. UWB has a precision that you can even actually detect whether a person is breathing or not. So this is actually the power of UWB. Now, talking about sub-gigahertz, this is yet another component. With RFID, you've got this really fantastic read range of a passive system, which is like 10 plus meters. UWB is an active system, can have much, much more range. And then we've got sub-gigahertz. Again, it's an active system. And when you're leaving your warehouse, for instance, with sub-gigahertz, you could actually track those products also when it leaves the warehouse in your metropolitan area or even beyond that, depending on how your system is set up. But that's the beauty of it. Now with RAIN RFID, you can track what product it is, how many it is, what has entered your DC, what left your DC. UWB tells you the exact location if needed. And then with sub-gigahertz, you could actually even track it beyond it once it leaves your warehouse. So with all of that, as I said before, we in NXP see a future where actually there's no one-size-fits-all solution out there. It's really where every item tells a story from its origin, also proving its authenticity, by the way, which is also an important thing. It's getting more and more important as we move on. It's actually also where you can track its journey, and really unlocking the true potential of data is about combining the data and making the most sense of it. This is, I think, which gets us to the big number of trillions. So with that, again, I want to thank you everyone for your attention. And Mark, I was a little bit concerned about your statement in the morning, not getting beer in Prague without cash. So next time around, we'll actually do a bar tour and make sure that all these pubs are actually offering NFC payment solutions. All right, thanks.